Hey everybody, it's time for our next installment of our class on apologetics. And this is, I think, our last class that we're going to have that is based on science as a whole. And then we're going to move from here, after we get done with tonight's discussion, we're going to move on to talking about some more philosophical things like pain and evil and suffering, what to do about the lack of fairness and justice in our world. Those will be good things to discuss, especially considering the current situations going on in our world. We are planning to have a class on the Trinity and the resurrection. So there's still a lot of things to come, but we're going to move away from science and back into probably much more Bible-heavy topics and looking up passages and things like that. But before we leave science and our discussion of science, there's an important area of science that we should be discussing, which is physics. A lot of science, mainstream science, has moved into talking about physics and theoretical science and those types of things. And so physics is on everybody's mind, at least in the scientific community. And so it's good for us to discuss what does physics say about the possibility of God and about what we should do regarding our faith. I actually call physics the believer's science. And what I mean by that is physics is in a lot of ways studying what is not observable by human senses. Physics, because it isn't studying cellular structure, it isn't studying physical systems, it's not studying dirt like geology or formulas and chemicals like chemistry. Physics is studying things like light and motion and those types of things that are just, they're part of our physical world, but they are not necessarily the visible parts of our physical world, and therefore this becomes a more interesting area of study when it comes to the concepts of faith and believing in the unseen. Well, let's go ahead and move on and start with a definition of physics, because I think that becomes important for us as we try to dig into what we believe about science and what we believe about physics as a whole. Here's the definition we're going to work with. It is a branch of science concerned with the nature and properties of matter and energy. The subject matter of physics, distinguished from that of chemistry and biology, includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structure of atoms. And by atoms, it's not necessarily the individual pieces of atom, but how do atoms hold together? How do they function? What about their movement? How does they interact with one another? And so physics gets into all that. Physics is really, as much as the other areas of science is the study of the seen, physics is the study of all the unseen things. It's how things work, it's movement, and those types of ideas. And so physics has a lot of rules that they have discovered based on science, or based on their observation of our world, which again is interesting because a lot of what it has discovered in a lot of ways goes against the theoretical ideas of how our world came to be. For instance, and again, we've already said this, biology and chemistry are a study of the concrete. Physics in a lot of ways studies the abstract, the unseen, and it allows for a lot of conjecture. It allows for a lot of theorizing into how these things work, because you can't always so clearly see. There's a lot of laws of physics, like the first law of thermodynamics, which you've probably heard of. It's the total energy of an isolated system is constant. Energy can be transformed from one form to another, but can be neither created nor destroyed. And so basically it's the idea that energy, and some will even say, matter in a lot of ways as it interacts with energy, cannot be created or destroyed. They are just, it is what it is. It stays in its current state. Not in its current state, but it continues to exist even when it changes states. The easiest way to understand this would be if you were to start a campfire outside. While the beginning of the campfire is a large heap of wood, and you've got the energy of the fire that is burning up the wood. At the end of the campfire, it looks like you have a much smaller amount of matter there because the energy has eaten it up. But if you were to gather together all of the energy, all of the vapor, all of the smoke, all of the ash, all of the every part of that campfire, and you put it back together, you would still have the same amount of matter, the same amount of energy. And so it's that idea that we're not destroying things, we're not creating things, at least in a natural order of the way things work. Now, that runs us into a problem with the concepts of any sort of creative or beginning theory, like the Big Bang or any other scientific theory, because by law, meaning the law of thermodynamics, they cannot naturally come up with a theory of where things came from because nothing can be created or destroyed. All of matter and energy had to exist in its fullest measure in the beginning, and there's really no scientific explanation as to where any of that matter and energy came from. All they can do is talk about how it has transitioned from one form to the next. So you take the Big Bang Theory, they will say that all of the matter of our entire universe was compressed together into one small little compact globe or circle or whatever shape they would say, and that when the Big Bang happened, all it did was change the form of that matter and energy, but all the matter and energy was there because naturally matter cannot be, or energy cannot be created or destroyed. And so that runs them into a difficulty of being able to really come up with a concept or a theory of how things were created or how they came to be. There really is no logical scientific explanation of that. The second law of thermodynamics is that the total entropy of an isolated system can only increase over time. Essentially what this is saying is that entropy or decay or destruction, that it is something that is completely, it is deteriorating at all times. The best way to illustrate this is imagine a house, but nobody has entered that house for the last 5 years. Does that house look the same as it did 5 years ago when the last person exited the house? Absolutely not. Things deteriorate, things fall apart. Our natural world is constantly falling apart. It can remain constant in ideal cases where the system is in a steady state or equilibrium or undergoing a reversible process. But the idea is that things naturally entropy, they naturally deteriorate. And the only way that it can't is for some other force to act on it in some way. Now again, this runs us into some trouble because there are a lot of things about our world that are not necessarily going through the process of entropy. Remember we talked about the sun, and that the sun is in some ways revitalizing itself. It is running through cycles. It is not deteriorating like it was always assumed to be deteriorating, but instead it is kind of refreshing itself. And so there we run into some difficulties. Our world tends to deteriorate unless there is an intelligent or some sort of other force that reverses that process. And so there's a force that is reversing that process for our world in some ways. The third law of thermodynamics is that an entropy of a perfect crystal at absolute zero is exactly equal to zero. So basically says if things are absolutely perfect, nothing entropies, nothing deteriorates. But that situation, that condition isn't really realistic. There's the Albert Einstein theory of relativity, which is at this point being questioned in the scientific community. But it's basically, special relativity versus general relativity. Special relativity applies to elementary particles and their interactions, describing all their physical phenomena except for gravity. General relativity explains the law of gravitation and its relation to other forces in nature. It applies to the cosmological and astrophysical realm, especially astronomy. So basically what's being said is that famous old E equals mc squared, that concept, that theory, that formula is basically the theory that time works in a certain way depending on because the other aspects of matter and gravity are constant. The problem we're running into is there's now theories that maybe when there are different levels of gravity, that time works differently in different places, and there's all sorts of different theoretical ideas that are throwing even the most basic of theories that we have about our world into question. Newton's 3 laws of motion. One is that in an inertial reference frame, an object either remains at rest or continues to move at a constant velocity unless acted upon by a force. So it's saying that if there's no resistance whatsoever, if a ball is rolling across the ground and there's no resistance, that ball will continue to roll across the ground at the same rate unless it is acted on by another force. And so that's the first law. The second law is that basically every action has an equal or opposite reaction. You maybe have heard that expression before. And so the vector sum of the forces F on an object is equal to the mass of that object multiplied by the acceleration of the object, or F equals ma. What that means is basically, in order to move something, there must be an equal or greater force causing it to move, or it won't move. Simple idea. If there's a big rock, I either have to be strong enough to move that rock, or that rock stays in place. The third law, when one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in the direction on the first body. There's that, every reaction has an equal and opposite reaction. That's the law there. And what that basically, again, with that rock, if the rock weighs 100 pounds, I must put 100 pounds of lift on that rock in order to move it. If the rock has a greater force of weight compared to my strength, well, then the rock will stay in place. There must be a greater force in order to cause it to work, because its force is working against my force. Now, again, the reason this becomes important is because it conflicts in a lot of ways with a lot of the other things that scientists have said regarding the Big Bang and other creation theories. What was it that caused the original reaction to happen? There must have been if the Big Bang or some of these other theories are correct, what was the cause that made those things happen? According to Newton's laws of motion, there must be a greater cause to make those events happen than the events themselves. And we can't come up in any way with any sort of explanation as to what those things might have been. The invariance of the speed of light. This is another one of those things that's questioned, that astronomers have always said that the speed of light is a certain rate, that it runs at a certain miles per hour, and I can't remember what that number is, but it is a massive speed by which light moves. That's the reason if you see a gun, someone shoot a gun across the field, you will see the burst of the gun. You will see the action before you hear the action. Same thing with a firework. Shoot a firework up in the sky, you will see the explosion before you hear the explosion. So speed has a much greater speed. It works consistently. But astronomers are now wondering if across our universe, as gravity has changed, or other things in the universe are different than the way they are here, maybe the speed of light works different. Maybe light moves much quicker in space than it does here on Earth in our atmosphere and in our environment, and that's shaking things up a little bit in the scientific community. The theory of the Big Bang is, if you look at it and compare it to all of these very basic laws of physics, what you find is the theory of the Big Bang absolutely flies in the face of a lot of the things that we say are part of the natural order of our universe. It breaks many of the scientific laws of nature and physics in order to even suggest that the Big Bang is even possible. Not only do we have a necessity for the creation of matter, because there's really no explanation of how matter came to be a compressed piece of matter that was acted on by energy outside of that matter. Where did the energy come from? Where did the matter come from? It doesn't even answer the question of origins. It just answers the question of maybe how did our current universe get to the state that it is in? But then even outside of that, to argue that the Big Bang or some of these other theories even happen goes completely in the face of all the laws of physics. So maybe all the laws of physics as we currently understand them didn't exist then. But if they didn't, how did they come to be? It raises so many questions because it contradicts so much of what we know about our natural universe. The only reason to really believe in the Big Bang is for the need of having an explanation of beginnings. It's based entirely off of assumptions. It's based entirely off of scientific observations of our modern nature, our current way of existence. And then you add that together with the fact that it breaks so many laws of our modern nature, it becomes a very hard theory to believe in. Why believe in something that breaks even the very laws, the very fundamental understandings of how our universe works? There's no reason for it. If I truly am a naturalist and I feel things need to be explained by natural means in a natural order, the way the natural world works, I cannot believe in the theories that scientists have come up with to explain human origins. And because physics is abstract, it oftentimes leaves a lot more possibilities open to scientific mind. There's a guy who came out years ago named Michio Kaku. He's famous for developing string theory. You've probably heard that. You probably don't have a clue what it is. I don't have a clue what it is. But he also became famous because he concluded that primitive semi-radius tachyons, which are the gaps between the tachyons, and talking about the way atoms work and how everything fits together, that they have the ability to unstick matter in the universe, leaving everything free from the influence of the universe. And what he says is basically, he believes that the universe could have been created through the design, not through random chance, because there really is no explanation whatsoever as to how the universe holds together unless it was designed to work that way. He proposed that there is not the Christian God, not the Jewish God, not the Islamic God, but there is a God of order to it all. That there is a superior force of some intelligence, of some ability that has made our universe possible based on the things he has learned and studied through physics. Now, I say all that to say, we as Christians, I think, sometimes feel embarrassed that what we believe is so contrary to what academics or what those who have been proclaimed to be intelligent believe. And nothing could be farther from the truth. We believe what we believe because there is plenty of evidence for it, both within the Bible, both within secular historical record, evidence within archaeology, and evidence even within science itself. God has left evidence of himself everywhere. And so when God says the heavens declare the glory of God, the firmaments declare his handiwork in Psalm 19, and we see passages like Romans 1 proclaim that he has put evidence of himself, of his nature within the world around us. That is true both on the atomic level, on the level in which we can see, on the bacterial level, when we look at the flagellum and the cilium, and when we look at the cosmological level and how the universe fits together and how it all holds together. There is nowhere you can look in our universe and not see the evidence of God. When we see just how ordered and perfect our universe is, And when there is no scientific explanation that you can give that doesn't break dozens, if not hundreds, of the laws that we have observed in the natural world around us, what other theory do we have than the truth that the Bible has delivered? God is real. And we should speak with confidence about who he is and what he teaches, and that he is our God and that he is creator.